Hello and welcome back to our C programming tutorial series. Today we are going to dive into the world of variables, and specifically we are going to learn about variable declaration, variable initialization, variable assignment, using a fun analogy of a particular case study that involves voltage, resistance, and current. So let's get started. Let's begin with variable declaration. In programming, a variable is like a container or a storage space that temporarily stores a value of a given type. The name that it uses is normally used to refer to that specific storage space or that memory storage location. Let's give an example. When you look at those particular rooms, every hotel will have a room. That room temporarily accommodates a visitor for a given period. So if you have booked for 1 day, after you check out, another person can use the same room. Those room numbers 101, 102, and so forth, they represent, or they are indicators to that particular storage space. They help us to easily identify that storage location. So in the same case, we are going to say that to easily locate a storage location, we normally use something we refer to as a variable name. We are going to use the following case study. That imagine you are an electrical engineer, you are working on designing a power supply for a new product, and you have been tasked to determine the correct resistance value for the load to achieve a desired voltage and current. And in your case, you're supposed to come up with a program that will store the value for voltage, will store the value for current, and calculate the resistance, and should be in a position to display that particular resistance. From this particular case study, you're going to see that you'll be required to create a storage location that will store for us voltage, a storage location that will be required to store for us the current, a storage location that will be required to actually store for us the resistance once it has been calculated for it to be displayed. How do we declare a variable? To declare a variable, we normally begin with a data type, then we follow with a variable name. As we have seen in our given case study, is that we needed 3 variable names, or more or less like the way we were saying room numbers, that helps us to identify the location of a given room. So we need 3 variable names that can help us to identify those storage locations. So the first one is voltage, the second one is current, the third one is resistance. We are using the word double. Double is a data type that implies that the voltage value, the current value, and the resistance value is likely to have decimals in it. And that's why we are using a data type called double. In the event you realize that your variable names are sharing the same data type, you can list them on one line and you separate them with a comma. And this helps you to avoid repeating the word double multiple times. Moving on, let's look at variable initialization. We are still going to use this particular case study. Of importance, you're going to now see that our voltage has been put an initial value of 30 volts, and we are being told that our load has a current of 2 amperes. So we already have a specific voltage, we already have a specific current, and that value has already been preset for us. So what do we mean by variable initialization? This is a process of storing an initial value to a declared variable. In our given case study, we are already being told that the voltage is 30 volts and the current is 2 amperes. The syntax normally is data type followed by the variable name, and then use this assignment operator, and then you place your initial value. So still relying on our particular case study, our voltage is 30 volts, current is 2 amperes. So how are we going to do it? We are going to state double voltage, and then we assign it 30.0. Double current, and then we assign it 2.0. In the event we do not want to keep repeating ourselves, we can use the multiple declarations by separating with a comma and simply state double voltage, and then we assign 30.0, comma, current, we assign it 2.0. In this given case, we are simply saying that voltage has an initial value of 30 and our current has an initial value of 2. Finally, let's look at variable assignment. In our given case, you are going to say that resistance did not have any initial value allocated to it, simply because resistance is supposed to be computed from voltage and current. So what is variable assignment? Variable assignment is the ability to allocate a value to a previously declared variable, or to allocate a new value to a previously initialized variable. The syntax normally is variable name, and then you assign it a particular value and you end with a semicolon. In our given case, you'll say that we have line 5, which you are referring to as variable initialization. Our line 6 is what we are referring also to variable initialization. Our line 7 is what we are saying, or we are referring to as variable declaration. However, you are going to say that at line 10, resistance is now having a value. And this value is actually going to come as a result of this computation. Once we take our voltage and we divide by current, we are going to get a value, and that value is what we are going to assign to the resistance. So we are going to have now resistance, this assignment operator, and then the output of this will be that new value. Combining everything, we now have our complete program, and you can see that all the declarations are normally declarations or initializations normally happen at the upper part of your given program, and then any other manipulation that needs to happen follows henceforth depending on the nature of your program. And then on our line 12 is where we are displaying our output. Remember, our case study implied that we are supposed to compute our resistance and display. So to display it, we are going to have resistance needed. The percentage dot 2 implies up to what decimal places? So dot 2 implies up to 2 decimal places. So long float, just that implies the data type, which in other words implies the size of the float. And then of course we normally separate with a comma and we display our given variable name. When you run this particular program, it's going to output resistance needed, and then it's going to place the percentage dot 2 F RF and then ohms. So at the place where we are having this percentage dot 2 LF, this is where we are going to substitute with our value, and that's why you're going to see that your program now displays resistance needed 15 ohms. I hope you have found this tutorial helpful. Be sure to like this video, subscribe to our channel, hit the notification bell to stay updated with more programming tutorials. As always, thanks for watching and happy coding.